Kinematics is the study of motion, and the kinematic variables are time, position. I'll write x, but remember it could be y, it could be z, it could be r, it could be s, it could be theta, anything that's describing position. Velocity, that could be along any of those coordinates, and acceleration also could be along any of those coordinates. So these are our kinematic variables. Now, a big question is, well, what causes the motion? These describe the motion itself, but what causes the motion? And that is with forces. Okay? Forces cause accelerations. That is the connecting piece. These describe the motion, and forces are what cause it. And we have a lot of different ways of analyzing forces to understand the acceleration that will result. The way these two are related is through Newton's second law, which you may have seen or heard written this way: F equals ma. Okay? And that is true. That's a true relationship in its simplest conceptual form. Okay, but I like to write it this way: A equals F over m. You see, algebraically it's the same thing, but what's important here is this emphasizes that I'm applying a force to something with mass and causing it to accelerate. The acceleration is the result of applying the force to the object with mass. Okay? Now, this of itself is a great, just without any embellishments or modifications, this is a great way of thinking about how accelerations and forces are related. But we're going to go through and make this a little bit more precise, a little more general, by emphasizing that, well, acceleration we've learned is a vector, okay, which means force is also a vector. Mass is not a vector, it's just a scalar, it's just an amount, okay, which means force is also a vector. That means all the care we took to figure out components of acceleration, we need to figure out the care, or do the same care to figure out the components of force, relating just the correct components together. Okay, so I'm going to write a little direction here. This suggests that AX is equal to FX over M, and I'll say AS is equal to FS over M, and I could keep going with Y and Z and R and anything else. Okay, that the force could be broken up into components, and it causes only an acceleration in that same component. So this is a little bit more helpful in being careful about how forces work. They are vectors. Another thing to embellish this is to talk about, well, an object could have forces on it but not necessarily accelerate. Why is that? Well, it's because it's not about just a force, but it's about the net forces, the combination of all the forces acting on that mass. Okay, and we'll go into detail about finding net force, identifying forces, trying to understand their direction and how they add together vectorially to find that net force. And therefore, then we can find the acceleration. And so, if there's no net force, even though there are multiple forces, but they might be opposing each other and be of equal magnitude, then there would be no acceleration. And that actually results in a different law. This is Newton's second law. That would result in Newton's first law that says an object without a net force won't accelerate, which means it could just keep moving without speeding up or slowing down. But this is the most fundamental way of looking at Newton's second law. And we're going to now focus on this piece of it. But remember, the whole goal is, now we're going to focus on forces. Our whole goal is to recognize how it causes accelerations that then cause motion, which we can observe, describe, and infer other properties from.